this brief presentation, we will review the recommended criteria for choosing a DSPLL for network synchronization applications, including Synchronous Ethernet, SyncE, SONET, and SDH. Applications that need network synchronization are typically governed by industry standards, including Synchronous Ethernet or SyncE, SONET, SDH, OTN, and Telcordia. All of Silicon Labs' latest DSPLLs support all of these standards. Silicon Labs' 534X, 8X clocks can be characterized as either jitter attenuators or synchronization clocks. The 5342 through 47 devices are Silicon Labs' latest generation of high-performance jitter attenuators. These devices use a single crystal frequency reference. The SI5348, 83, and 84 synchronization clocks use two frequency references, a crystal and a stable TCXO or OCXO oscillator. Regardless of the architecture, all Silicon Labs 534X, 8X clocks have many competitive advantages. These devices have the industry's lowest jitter, the frequency synthesis provides the best-in-class frequency flexibility, the DSPLL is a digital circuit design that is not susceptible to PLL crosstalk or power supply noise, and Silicon Labs Clock Builder Pro software greatly simplifies the design process for customers. The simplest network synchronization timing architecture is commonly referred to as the centralized architecture or pizza box. In this architecture, a low bandwidth PLL is used for SyncE or SONET SDH wander attenuation, and to provide a holdover function if input clocks are lost. Then a follow-on jitter attenuator is used to generate a low jitter transmit clock for the PHY or SerDes devices. These components are usually all in the same PCB. Note that two PLLs are required to create low jitter output clocks. Silicon Labs recommends the SI5348, 83, and 84 devices for pizza box applications. These clocks offer a huge advantage over competitors because one of these replaces two competitor chips. The 5348, 83, and 84 devices not only have the low bandwidth wander and jitter attenuation needed for network synchronization, but also provide low jitter output clocks for PHY and SerDes devices on the PCB. In addition, the 5348, 83, and 84 devices support 1 PPS or 1 Hz signals for phase synchronization and contain up to 3 PLLs per device for high levels of integration. The second type of network synchronization timing architecture is the distributed architecture. In this arrangement, redundant primary and secondary timing cards contain low bandwidth PLLs for SyncE or SONET SDH wander attenuation and holdover. Then the clock outputs from the timing cards are distributed over a backplane to several line cards. Each line card has a jitter attenuating clock to provide low jitter clocks to the PHY or SerDes devices. A similar arrangement is used for wireless infrastructure applications. However, in wireless infrastructure, the timing cards are sometimes referred to as control boards, and the line cards are sometimes referred to as baseband boards. In the distributed timing architecture, Silicon Labs recommends using the SI5348, 83, and 84 synchronization clocks for the timing card designs, and then using the 5342 through 47 jitter attenuators for each line card. On the timing card, the synchronization clocks perform wander attenuation and generate clock outputs for each line card. Since each line card already has a jitter attenuator, you might think it's not necessary for the outputs of the timing card to have low jitter. While this is true, many competitors still need low jitter output clocks for other functions on the timing card. As a result, synchronization clocks are a good fit for the timing card designs. In addition, the 5348, 83, and 84 supports 1 PPS or 1 Hz clocks, which are often used on timing cards for phase alignment. For the line cards, the 5342 through 47 devices have the industry's best jitter performance. This is critical for any design that supports data rates of 10 gigabits per second and higher. The embedded multisense are also useful for generating clocks for other components on the line card. One final comment is that some competing devices for timing cards offer a higher number of inputs and outputs than the 5348, 83, and 84. If a customer needs more outputs than what we can provide, the SI533XX buffers offer a cost-effective fan-out option with only 45 femtoseconds of additive jitter. If a customer needs more inputs, this muxing can be done in an FPGA that may already exist on the timing card. If this might be useful for one of your customers, contact Silicon Labs for more information about available FPGA source code for input clock muxing. In summary, with just a few questions, it's easy to decide which DSPLL device should be used in a customer application. All that's needed is to know if the design is for wireline or wireless, what's the timing architecture, and what type of application is being designed. For future reference, you can use this selector guide next time you visit a customer interested in timing synchronization. Save a copy to your PC or keep a printout with you for quick reference. If you'd also like more information about how the SI534X and 8X devices should be used for synchronization applications, download the app note AN1077, selecting the right clocks for timing synchronization applications, from www.scilabs.com.